Hello friends, I am Kirtir DB, junior college teacher, सद्गुरू गाडगे महाराज कॉलेज कराड. सर्वप्रथम आपलं सर्वांचं सद्गुरू गाडगे महाराज कॉलेज मध्ये स्वागत करतो. इयत्ता 11वी सायन्स मध्ये प्रवेश घेतलेल्या सर्व विद्यार्थ्यांसाठी पहिल्यांदा तुमच्याशी थोडंसं चर्चात्मक बोलणार आहे. आज अखेर फिजिक्स या विषयामध्ये पहिला चॅप्टर सेक्शन फर्स्टचा श्री माळवदे सर यांनी तुम्हाला पूर्ण शिकवलेला आहे. इयत्ता 11वीला एकूण 14 चॅप्टर आहेत. चॅप्टर म्हणजे धडे, प्रकरण, एकूण 14 प्रकरण पैकी पहिली 7 प्रकरण ही सेक्शन फर्स्टसाठी असतात आणि दुसरी 7 प्रकरण सेक्शन सेकंडसाठी. त्यातील सेक्शन फर्स्टमधील पहिलं प्रकरण युनिट्स अँड मेजरमेंट हे तुमचं पूर्ण झालेलं आहे. आज आपण सेक्शन सेकंडमधील पहिलं प्रकरण, त्याचं नाव आहे इलेक्ट्रिक करंट थ्रू कंडक्टर, हे आपण आज चालू करणार आहोत. मित्रांनो, इयत्ता 11वी सायन्समध्ये प्रवेश घेतलेले जे विद्यार्थी आहेत ते खेड्यापाड्यातून येत असतात. त्यामध्ये 3 टाईप्स असतात. एक मराठी मीडियमचे, दुसरा टाईप सेमी इंग्लिश आणि तिसरा टाईप कॉन्व्हेंट. अशा 3 टाईपचे विद्यार्थी आपल्या कॉलेजमध्ये प्रवेश घेत असतात. तर शिकवत असताना आमची कसरत होते, नक्की कोणत्या भाषेत शिकवायचं, मराठी शिकवायचं का इंग्लिशमध्ये शिकवायचं. तर आपण त्याचा मध्य साधतो, इंग्लिश मराठी असं मिक्स टीचिंग आपण दरवर्षी करत असतो की जेणेकरून शिकवलेला भाग विद्यार्थ्यांना समजावा. त्या दृष्टीनं आपण तसा प्रयत्न करूया. ह्या कोविड-19च्या प्रादुर्भावामुळं आपलं कॉलेज रेग्युलर होत नाही. आपण सर्वजण ऑनलाईन टीचिंग करतो आहे. तर ह्या कोविड-19च्या प्रादुर्भावामुळं शासनानं जो सिलेबस दिलेला आहे 11वीचा, त्यातील काही भाग रिड्यूस केलेला आहे. म्हणजे साधारणपणे 20-25% सिलेबस प्रत्येक चॅप्टरमधला भाग शासनानं रिड्यूस केलेला आहे. त्याचप्रमाणे ह्या चॅप्टरमधला म्हणजे सेक्शन सेकंडमधला पहिला चॅप्टर आपण जो आज शिकवणार आहोत तो म्हणजे इलेक्ट्रिक करंट थ्रू कंडक्टर. ह्यातील एकूण 7 पॉईंट्स सिलेबसमधून कट केलेले आहेत. ते एकूण 7 पॉईंट्स कोणते आहेत ते पहिल्यांदा आपण बघूया. त्यातला पहिला पॉईंट आहे तो म्हणजे इलेक्ट्रिक करंट. दुसरा फ्लो ऑफ करंट थ्रू कंडक्टर. तीसरा ड्रिफ्ट स्पीड और वेलोसिटी. फोर्थ पॉइंट ओहम्स लॉ and its limitations. Fifth, electrical energy and power. Sixth, specific resistance also called as resistivity. 7 point resistors. हे एकूण 7 पॉईंट्स ह्या चॅप्टरमध्ये रिड्यूस केलेले आहेत. म्हणजे कमी केलेले आहेत. फक्त ह्या वर्षासाठी 2020-21 ह्या शैक्षणिक वर्षासाठी एवढे पॉईंट्स त्या चॅप्टरमधले रिड्यूस केलेले आहेत. हे पॉईंट सोडून इतर जे पॉईंट्स आहेत या चॅप्टरमधले ते आपण डिटेलमध्ये तुम्हाला शिकवणार आहोत. परंतु हा चॅप्टर जर तुम्हाला समजून घ्यायचा असेल व्यवस्थित तर ह्या गोष्टी तुम्हाला थोड्याफार माहीत असणं गरजेचं आहे. इयत्ता 10वीपर्यंत तुम्हाला ह्या चॅप्टरसंबंधी थोडीफार माहिती आहे. म्हणून आपण सेक्शन सेकंडमध्ये पहिला टॉपिक जो शिकवायचा आपण निवडलेला आहे तो म्हणजे इलेक्ट्रिक करंट थ्रू कंडक्टर. का तर तुम्हाला ह्याच्याविषयी तुम्हाला थोडं बेसिक माहिती आहे. तर आपण सुरुवातीला ह्या पॉईंटविषयी थोडीशी चर्चा करूया की जेणेकरून तुम्हाला थोडीशी त्याच्याविषयी आयडिया येईल. तर चॅप्टरचं नाव काय बघा, इलेक्ट्रिक करंट थ्रू कंडक्टर. तर पहिल्यांदा इलेक्ट्रिक करंट म्हणजे काय हे आपण थोडक्यात पाहूया. तर इलेक्ट्रिक करंट म्हणजे काय हे पाहण्यापूर्वी आपण कंडक्टर म्हणजे काय हे पहिल्यांदा बघायचं होतं आपल्याला. कंडक्टर, व्हॉट इज मीन बाय कंडक्टर? दिस इज कंडक्टर AB of any metal. All metals are conductors. Consider one of the metal, for example copper. This is copper conductor. Any conductor is made up of large number of atoms, and these atoms are close to each other. In case of atom, there is central nucleus contains protons and neutrons. Protons having positive charge, neutrons are neutral particles. So charge on nucleus is always positive, and electrons revolve around the nucleus in different circular orbit. Electrons having negative charge. The electrons in the outermost orbit of an atom of that substance or metal are called as free electrons or valence electrons or conduction electrons. These electrons takes part in the conduction of electricity, that is electric current, to that conductor. To understand the concept of electric current, consider this conductor consists of large number of electrons like this. These are electrons. Electrons having charge E. Electrons are negatively charged particles. In absence of any external potential across that conductor, these electrons are free to move in all possible directions within that conductor. That is, these electrons are randomly moved within that conductor like this. Suppose this electron move towards left, this move towards right, down, this move towards right, this move towards up. That is, in this way, all the electrons within that conductor move in all possible directions within that conductor with a random speed or velocity. A random speed of electrons within that conductor is near about 10⁶ meter per second. According to definition of electric current is nothing but a rate of flow of charge to that conductor or flow of charge with respect to time is known as electric current. Suppose E be the charge on electron. These electrons move within that conductor in all possible directions. So net flow of charge to that conductor given by this Q is equal to NE, where N be the number of electrons and E be the charge on single electron. Charge on single electron is equal to 1.6 into 10⁻⁹ coulomb. N be the number of electrons, if the charge on single electrons gives us total charge Q. flows through the conductor. In this case, the net charge flowing through the conductor is equal to 0 in absence of any external potential across that conductor. As there is no charge, therefore electric current I given by I is equal to Q divided by T, where Q is the charge flowing through the conductor within time T. In this case, Q is equal to 0, so net current flowing through that conductor I is equal to 0 in absence of any external electric field or external potential across the conductor. To understand this concept of electric current, there is a flow of charge within that conductor expressed in a particular direction. Suppose this is cross-section area of that conductor. To flow the current through that conductor, charge always flows through that section of conductor in any given direction. But in this case, there is no charge flows through that section of conductor in any given direction. Therefore, net current through that conductor equal to 0. This is about electric current. From this formula, we can calculate the unit of electric current. I is equal to, here charge is measured in terms of coulomb and time is measured in terms of second. Therefore, coulomb per second commonly named as ampere. So, SI unit of electric current is ampere. In case of semiconductor devices, electric current is measured in terms of another units like milliampere, microampere and nanoampere. This is about electric current. Electric current can also be written like this. I is equal to dq divided by dt. That is rate of flow of charge, means electric current given by the formula I is equal to dq divided by dt. This is instantaneous current. That means current flowing through that conductor during particular time called as instantaneous current given by the formula I instantaneous equal to dq divided by dt. Also, current can be written like this: I is equal to delta Q divided by delta T. Average current flowing through the conductor, I average equal to delta Q divided by delta T, or I average equal to Q final minus Q initial divided by time final minus time initial. These are some formulas useful for solving problems in this chapter. So, these formulas are most important for solving the problems or numericals within this chapter. This is about concept of electric current. Electric current flows through the conductor only when potential difference is applied across the ends of the conductor. Suppose this is conductor AB, consists of large number of electrons. In absence of external potential, these electrons move randomly within that conductor with random speed. Suppose a potential is applied by means of battery across the conductor like this. This is symbol for battery having two plates, one positive, second negative, having some potential V called as potential difference, because plate P is at positive potential, higher potential, that is connected to end A of conductor which is at positive potential, higher potential. Another plate having negative charge connected to end B of conductor, so end B is at negative potential, lower potential. That is, two ends of conductor are at different potentials. and A is at positive potential, higher potential, and B is at negative potential, lower potential. So there is potential difference across the ends of the conductor AB. That potential difference to be V. End B is at negative potential while end A is at positive potential. These electrons having negative charge. These electrons having negative charge, end B is at negative potential. So these electrons try to move towards end A because end A is at positive potential. While moving electrons from end A to end B collides with vibrating atoms within that conductor. These atoms opposes the flow of electrons. That opposition offered by the atoms within that conductor is known as a resistance of that conductor. So that these electrons try to move from end B to end A. End A is at positive potential, end B is at negative potential, so that an electric field is developed across the conductor denoted by symbol E. It is a vector quantity. It is always directed from positive charge to negative charge. Here electrons try to move from end B to end A because electrons having negative charge. This end B is at negative potential. So there is like charges, there is a repulsion between two like charges, so that electrons try to move towards left, collides with vibrating atoms. Random speed of electrons is equal to 10⁶ meter per second. When these electrons collides with atoms, the speed of electrons goes on decreasing. Finally, these electrons move towards end A of conductor with constant velocity. That constant velocity gained by the electron in a direction opposite to the direction of electric field. That velocity of electron is called as drift velocity, denoted by symbol Vd. Vd with the drift velocity of electron in a direction opposite to the direction of electric field. This is the direction of electric field, this is the direction of flow of electron with drift velocity. These two arrows are exactly oppositely directed. At the same time, the flow of positive charge takes place from end A to end B, and that flow of positive charge, nothing but electric current I, given by the formula I is equal to Q divided by T, or I is equal to NE divided by T. Here I with the direction of electric current, E with the direction of electric field. This arrow indicates direction of flow of electrons with drift velocity. Direction of flow of electrons. This arrow indicates direction of flow of electrons. Direction of flow of electron is exactly opposite to the direction of electric current and electric field across the conductor. Also, drift velocity of electron, the direction in which electron drifts towards end A with velocity V equal to 10⁻⁴ meter per second to 10⁻⁵ meter per second. This is the drift velocity of electron with which electrons drift towards end A from end B to end A, and direction of that drift velocity of electron is exactly opposite to direction of electric field. That drift velocity V is equal to 10⁻⁴ meter per second to 10⁻⁵ meter per second. Here I with the current, V with the voltage, and R with the resistance of that conductor. Scientist Simon Ogham gives one relationship between electric current I and potential difference V. That relationship is known as Ohm's law. That Ohm's law says that if the physical state of conductor, this is conductor AB, if the physical state of conductor remains unchanged, remains constant, that means physical state means material of the conductor, second dimension of conductor, and third temperature of conductor remains the same. The electric current I flowing through the conductor is directly proportional to the potential difference applied across ends of the conductor. According to that statement, we can write some relation I proportional to V or V proportional to I. That means V proportional to I. Replace this proportional sign by equal sign by taking some constant. That is V is equal to constant into I. V is equal to this constant replaced by a symbol R. Therefore, V is equal to IR. This is Ohm's law that we have already studied up to 10th standard. From this, we can write equation I is equal to V divided by R. If this voltage potential difference is kept constant, that is V is equal to constant, then I equal to constant divided by R, that is I proportional to 1 upon R. From this, as the resistance increases, current decreases. That means current is inversely proportional to resistance of that conductor. That means as resistance increases, current decreases. This is about Ohm's law, and some limitations are given in our book. Limitations of Ohm's law. Then some part, that is electrical energy and electrical power. These are some points to be deducted from our syllabus. But we know about some concept regarding these points. For that, we explain these terms. By considering all these terms, we start the first point of the syllabus. Another deducted part of the syllabus is a resistor. A resistor is one of the most important component of electric circuit. To be used in an electric circuit to limit or control electric current in a given branch of circuit. That resistor available in market are of two types. One, carbon resistor, and second, wire wound resistor. This is carbon resistor available in market. This resistor having a very high range. Such resistors are useful in electrical circuit to control or to limit current through any branch of that circuit. That resistance is called as carbon resistor. The value of that carbon resistor to be calculated with the help of color code scheme for resistor. That scheme we have also studied up to 10th standard. With the help of that tabular form, BB Roy, we can calculate the value of resistance of that resistor. Then The next point of that chapter is the rheostat. Rheostat, this is the instrument to be used in laboratory while doing practical. That instrument is known as a rheostat. This rheostat is one type of adjustable resistor to be used in an electric circuit to adjust the resistance current in any branch of circuit, as well as to adjust the potential difference between any 2 points within that electric circuit. That rheostat, this is the figure showing the rheostat. That rheostat consists of 3 terminals. This is terminal A, this is terminal B, and this is terminal C. There are 3 terminals of that rheostat. This is sliding contact to be slides over that coil of wire. This is a coil of wire. This is sliding contact touch with the coils of that wire, and this rheostat having 3 terminals, terminal A, terminal B, and terminal C. That rheostat to be denoted by symbol like this. This is symbol for rheostat. This rheostat having 3 terminals, terminal A, terminal B, and this is terminal C. C terminal called as variable terminal. Such rheostat to be connected in an electric circuit to control the resistance current within any branch of circuit, as well as to adjust electric potential or voltage between any 2 points within that circuit. Such figure or diagram is called as rheostat. In hi-fi instrument, such rheostats are used to control for the use of volume control. This is about rheostat. Thank you.